Hey folks, Mr. Dell here. We are exploring a problem where you have to do some graphing of coordinates, and then from that describe the shape that you've created when you connect the dots, and then identify some angle measurements, as well as also do a translation based on the shape you have. So this problem is specifically coming from CPM, and this is course 3, CC3 section 7.1.1, and it is one of the review preview questions 7-11. So it says, graph the following points on a coordinate grid, and gives us our points. So we'll talk about how to graph those coordinates, and then connect the points as you plot them. Then connect A to D. So you're going to be connecting A to B to C, C to D, and then A to D. So you complete your figure. Okay. Wants us to then describe the shape we've created, identify the angles at point C and D, and then record the new coordinates after you do a translation. So here we go. Let's start. So if we're going to graph this, remember the first thing is creating your X and Y coordinate plane, right? So your Y axis is always your vertical vertical axis. Your X axis is always your horizontal axis. I tend to always throw arrows on my axes to show that that's an infinite space. And then let's graph our points. Remember, your coordinates are always X comma Y. The first number is your X. The second number is the Y, right? So this being 0, 0, we know that on a coordinate system, these are the negatives. It's like a number line, right? So you have -1 this direction, -2, -3. And then in this direction, it's +1, 2, 3. So our positives go this way, negatives that way. This is always 0, 0. So the same thing with the y-axis. It's like a vertical number line, right? So you go up positive and down negative. So we end up going down negative. So those are just some labels there for our initial. So -3, 3 is my first point, and that's A. So -3, 3. Let's see, -3 on the X, -3 on the Y. Oh, I might have labeled this wrong. -1, -2, -3. So, oh no, that's right. I did that right. So there we go. That's -3, 3. And that would be A. So that's my coordinate A. I'll label it. B is at X is 3, Y is 0, 3, 0. So X is 3, Y is 0. So I don't go any up or down, but I do land right there where X is 3 on the X axis. C is 3, 6. Oh, this was B. 3, 6 for our C. So at 3 is the X. And so 3 is the X, 6 is the Y. So 3, and then I'm going to go up 6. So let's see, 1, 2, 3, 4, 5, 6. Count 6 up. And then D is at -3, +6. So we're up that direction. So, and this is D. So this was C and D. So it wants us to connect our dots. So if we connect all of our points, we will have what looks like, and then it asks us to describe the shape you created. Well, what we have, if you notice, you've got these right angles here, but then here, of course, there's not a right angle. But what I do see is when I have opposite sides that are parallel, right? These two sides are parallel. They run the same, but then these sides are not. That would be a trapezoid. So this is a trapezoid, right? You can maybe even see it better if I turn the paper. Now do you see that is a trapezoid? So it's a trapezoid that's kind of tilted on its side. So for part A, it says describe the shape you created. This would be a trapezoid. Okay, trapezoid. Identify the angles at C and D. Well, C and D, I kind of mentioned it earlier. If you look how they come up at a perpendicular, right? So this edge is perpendicular to those side lengths. So being perpendicular, you know that you have 90-degree angles here. You have right angles. So identify the angles. You could say, so angle C and D are right angles, or we could say 90 degrees, right? Right angles or 90 degrees. and then record the coordinates. So part C then record the coordinates of new points if you are to translate. So we're going to do translation of the original points 3 units left and 5 units up. So a couple things you could do. So we could just from the graph record them, actually take and go. So let's see, here's B. I can go from B, I can go 3 units left. So left is this direction, 1, 2, 3, and then 5 units up. So 1, 2, 3, 4, 5. So that right there would be my new B, calling my B prime. You could do the same thing with A, right? 3 units left, 1, 2, 3, 5 units, 1, 2, 3, 4, 5. There would be my A prime. But now I need to record them. I need them listed. So that's why I was going to just list them on the paper. You could draw it and then write the coordinates themselves. Or you could say that A prime is what? Well, it was negative 1, 2, 3, 4, 5, 6, and then 1, 2. So negative 6, 2. So we could look at the graph and record them. Or we can look at this translation, right? There's a way to define a translation. When you take a translation, you define it using the actual expressions. And this would be x is what? If it's going 3 units left, x is subtracted by 3, x minus 3. And the y, 5 units up, so it's y plus 5. So this is the description of the translation. So when I think of my original point, my original A, let me go up here. My original A, negative 3, negative 3. What am I doing? I'm going negative 3 minus 3, which is negative 6, and then negative 3 plus 5, which is 2. So I don't even need to look at my graph. I could define to show you where my B is, and we'll maybe check it. But I'm gonna actually use this and then plug it into my algebra here, plug it into my expression. So if my original B was 3, 0, my new B would be what? I'd go 3 minus 3, which is 0, and then 0 plus 5, which is 5. So my new B, and let's check if that's true. Is that at 0, 5? And if I look, sure enough, my B prime here is at 0, 5. So then C prime, we'll just keep using the expression. It's originally is 3, 6. So 3 minus 3, now it's going to be at 0. And then 6, so 6 plus 5, 11. And then my last point, D prime, originally is at negative 3, 6. So I go negative 3 minus 3, which is negative 6. And then 6 plus 11, or 6 plus 5, which is 11. So those are the coordinates of my new translated shape. All right. Okay. There you go.